Hi, this is Lisa. In this video, we're going to talk about two techniques of factoring. First, greatest common factor, and then we'll talk about factoring by grouping. The greatest common factor, or GCF, of two or more expressions is the product of all the common prime factors, using each factor the least number of times it's used in any expression. When you're finding the greatest common factor, you factor each term and form the product of all the common prime factors, using each factor at least the number of times it is used in any term. So let's do some examples where we find the greatest common factor for the given expressions. The first one, we're going to find the greatest common factor of 48 and 120. So I want to be able to factor 48. I'm going to make a factor tree. There are lots of different ways to factor 48. Just pick one to start with. 48 is 6 times 8. 6 I can break down. 6 is 2 times 3. 2 is prime and 3 is prime. I'm going to circle those numbers, and now I can stop factoring on that branch of my tree. 8 can be factored. 2 times 4. 2 is prime, so I can stop there, but 4 I can factor into 2 times 2. So 48 is equal to, I have 1, 2, 3, 4 factors of 2. 2 times 2 times 2 times 2 times 3. And then I'm going to do the same thing for 120. Any number that ends in 0 has 10 as one of its factors. So 120 is 10 times 12. 10 is 2 times 5. 2 is prime and 5 is prime, so I circle them. 12 is 2 times 6. 2 is prime, and 6 I can break down to 2 times 3. Both 2 and 3 are prime. So 120 can be written as, this time I have 1, 2, 3 factors of 2. I have 1 factor of 3 and 1 factor of 5. So to find the greatest common factor, my greatest common factor is going to be the combination of all the pairs that they have in common. They each have 1, 2, 3 factors of 2 and 1 factor of 3 in common. So 2 times 2 times 2 times 3, or if I multiply those out, 24 is the greatest common factor of 48 and 120. The next example we're going to look at has some variables in it as well. So I'm going to start with my numbers. And you do not always have to go down to primes if you notice what they have in common. When I look at 12, 36, and 15, I notice there's only one way to factor 15. So I'm going to write all 3 of my terms down here. And I'm going to start factoring. The only way I can factor 15 is 3 times 5. So I want to look, does 12 have a factor of 3 or 5? And 12 I can write as 3 times 4. So 5 is not a factor of 12. 36 I can write as 3 times 12. Again, 5 is not a factor there, but they all have a common factor of 3. So my greatest common factor is going to start with a 3. And then I look at the variable parts. When you look at the variables, you always want to look for the smallest exponent. In this case, it's 2. So I know every one of those terms will have x squared. So 36x squared has an x squared in it. X to the 5th I can break down as x squared times x cubed, right? When you're multiplying with same bases, you add the exponents. 2 plus 3 is 5. And likewise, x to the 7th can be written as x squared times x to the 5th, because 2 plus 5 is 7. So the greatest common factor is 3x squared, because they all have x squared in common. Now we're going to talk about actually factoring out an expression. So we're going to factor each term and find the greatest common factor. We will write down the greatest common factor, and in parentheses we write what's left after the greatest common factor is factored out of each term. So let's do some examples. 7x squared plus 21x. So when I look at 7 and 21, I notice 7 can't be factored, it's prime, but 21 can be factored as 3 times 7. And then I look at the variable part. This one only has one x in it, so they will both have one factor of x in common. And x squared can be written as x times x. So when I look at what they have in common, they both have a 7 and they both have an x. So I'm going to write the common factor down first, 7x, and in parentheses, what do I have left? Well, I have x plus 3 that I have not factored out of the expression yet. And on these, you can always check by multiplying back out. If I want to check to see if this is true, 7x times x is 7x squared, and 7x times 3 is plus 21x, and that does give me what was in the original equation, so I know my factoring here is correct. Example number 2 asks us to factor out a negative greatest common factor. I'm going to move this over. And then when I factor, I want to think about taking out a negative. I notice 5, 25, and 10 all have a common factor of 5. So I'm going to start by breaking this down as negative 5. And then plus 25 is negative 5 times negative 5. And minus 10 can be written as negative 5 times a positive 2. And I always look at the smallest number of x's that I have in any term. This one has just one x. X squared can be factored as x times x. And x to the 5th can be factored as x times x to the 4th. I'm going to take out my common factor is negative 5x, negative 5x, negative 5x. So I write down the common factor first, and then in parentheses, I look at what do I have left in my expression. I have x to the 4th, I have minus 5x, and I have a plus 2. And now my expression is completely factored. You always want to go back and look at what's back inside your parentheses to say, did I really take everything out that I possibly could? And when I look at what's left in my parentheses, x to the 4th and 2 have nothing in common. So I know it's completely factored. Example number 3 is a little bit different here. We only have one addition sign that's outside of our parentheses, so we want to look at what's inside the parentheses as being a factor. And if I have exactly the same things inside the parentheses and it's being multiplied by something else, that is going to be my common factor. So my common factor is x plus 5. And then I want to go back and look at what's left. I have x plus 7, so I put what's left inside parentheses. And then this expression is factored. Next, we're going to talk about factoring by grouping. You want to group the terms into pairs using parentheses. Keep a plus sign between the two sets of parentheses. Factor out the greatest common factor from each group, and then factor out the greatest common factor from each of those groups. So we're going to do an example here. Number 1, I'm going to insert my grouping parentheses, leaving that addition sign in between my two sets of parentheses. And I look to see what does my first group have in common. The first group has a common factor of a, and in parentheses, if I look at what's left, I have y plus 3. The second group, 6 and 18 have a common factor of 6. 18 can be written as 6 times 3. So I'm going to take out a common factor of 6. So I had the plus in between, and now 6 is my common factor, and what I'm left with is y plus 3. If you notice now, each of my groups has a factor of y plus 3. Those have to be exactly the same for them to be a common factor. If I take out my common factor and I look at what is left, a plus 6. And I can always check my factoring by multiplying that back out. Y plus 3 times a plus 6. Distributing y times a, or ay, y times 6, or plus 6y, 3 times a gives us plus 3a, and 3 times 6 gives us plus 18. Now these are not exactly in the same order as our original expression was, but if you notice, we have an AY, we have a 3A, we have a 6Y, and we have an 18. It checks. That is the original polynomial that we started with. So we know our factoring is correct. Example number 2. When I put parentheses here, I always want to have a plus in between. I can factor the negative out later on. When I look at my common factors, 2a squared plus ab gives me 2a times a plus a times b. My common factor here is a. I'm going to write the common factor down, and what's left is 2a plus b. And now when I look here, I have a common negative sign. I need to factor out the negative, and I also have a common factor of b. So this becomes negative 2ab minus b times a positive b. And so I'm going to factor out the negative sign and one of the b's, the negative sign and one of the b's. So negative b is my common factor, and what's left is 2a plus b. Again, when we look, what's inside parentheses is exactly the same. 2a plus b, 2a plus b. That's my common factor. And in parentheses, what's left is a minus b. And there is my polynomial in factored form. Example number 3, we're going to start off the same way. I'm putting parentheses around the first pair and the last pair, first 2 terms, last 2 terms, and I need to factor out what they have in common. Again, I'm looking at my exponent here. Smallest exponent is 2. I can factor m squared as m squared times m, and then I have minus 2 times m squared. For the first group, m squared is the common factor, and what's left is m minus 2. Plus, this is 5 times m minus 10, which is 5 times 2. They have a common factor of 5, and in parentheses, what's left is m minus 2. Common factor here is m minus 2. And when I look at what's left, m squared plus 5. And my polynomial is factored. I've got 2 more examples for you. Again, I'm going to put parentheses around the first 2 terms and the last 2 terms with a plus sign in between. 6a squared plus 9a. 6 is 2 times 3, and a squared is a times a, plus 9 is 3 times 3, and we have one factor of a. So I can take out 1a and 1 3. 3a is the common factor, and what's left is 2a plus 3. Now here I've got a common negative sign that I can take out again. 12 and 8 have a common factor of 4, so I'm going to do this as negative 4 times 3 times b, and 8 is negative 4 times a positive 2 times a times b. So negative 4b is my common factor, and in parentheses what's left is 3 plus 2a. Now if you look closely, what's inside the parentheses is the same. I have 2a and I have a plus 3 in each set of parentheses, so even though they're in a different order, it's still exactly the same amount. 2a plus 3 is my common factor, and in parentheses what's left is 3a minus 4b. And our factoring is complete. Last problem here. Again, I'm putting parentheses around each of my first 2 and last 2 terms here. And when I look, 4x squared and 7y have nothing in common. Oftentimes when that happens, you can flip the middle 2 terms. I'm going to write this as 4x squared plus 2x. and then plus 7y plus 14xy. And now if I look at the first two terms and the last two terms, now they have common factors. Factoring out common factor here, 4 is 2 times 2, and x is x times x. Sorry, x squared is x times x, plus 2x, 2 times x. When I look now, they both have 2x as a common factor, and what I'm left with is 2x plus, and there's nothing left there, but remember, 1 is always a common factor. Even if it's not written there, 2x is the same as 1 times 2x, so what's left there is the 1. 7y plus 14, this is 7 times y plus 14 is 2 times 7, and I have an x and a y. Again, I'm crossing out the 7 y's. Those are my common factors. And in parentheses, if there's nothing left, we're going to leave a factor of 1. So 1 plus 2x. And again, these are in a different order, but they are the same amount. So 2x plus 1 is our common factor, and what's left is 2x plus 7y. And that concludes our video on greatest common factor and factoring by grouping.